wala pa tayo ng geometric series. So, ngayong session natin yun gagawin. Okay? Yeah, and we'll answer some examples about it. Now, first thing, ito muna exit ticket just so if I forget later on, no? Anyway, mapopost din naman to sa Google Classroom ninyo. Answer page 334, numbers 24, number 24, page 340, number 17 and 21. Okay? For your exit ticket, sabi to ni Mrs. Arespacochaga, gawin nyo daw yan before 6 p.m. today. Okay? And then read and understand your book chapter on sequences. And then prepare for the essay. Again, your essay will be next session. So in your case, Thursday. Sa mga last torta ko, Friday pa. Right? Now, there's also an error here. Nasaan na yun? Nilagay ko dito yun eh. Balikan ko muna yun. Ito, yung exit ticket from the previous session. Kung na-i-upload na ni Mrs. Arespacochaga yung answer key, may error dito sa answer key if you look at it. Sabi sa number 25, the population of a small town increases at the rate of 5% per year. If the present population is 500,000, find the expected population 10 years from now. So, in this case, we are looking for a sub 10, no? The 10th term in the sequence. However, ang mali dito ay ito, yung paggamit ng 500,000 as a sub 1. Kasi kung a sub 1 mo yung 500,000, then that is the current year. However, if we are looking for the expected population 10 years from now, so I imagine this, a year from now, that's a sub 1, that will be, instead of the 500,000, that will be the second year, no? Na nag-increase na ng 5%. So, ay dalawa ang pwedeng pang-rectify mo dito eh. Either, you treat 525,000 as the first term, that's option 1, or instead of looking for the 10th term, you look for the 11th term. If you decide to use 500,000 as a sub 1. No? Again, kung gusto mong ipilit na a sub 1 ang 500,000, no problem. Pero, instead of a sub 10 ang hahanapin mo, instead, you'll look for a sub 11. Okay? Now, either way, either a sub 1 mo, si 500,000, look for a sub 11, or gawin mong 525,000 si a sub 1, and then look for a sub 10. Either one should give you the correct answer, which is not 775,664. Hindi yan. Okay? You should multiply that by another 1.05. Dapat. Okay? Yan lang yung correction from the exit ticket from the previous session. Okay? Now, balikan natin ito, yung mga slides na in-skip ko. Quick review, because this is the last session again, before the summative. We talked about sequence functions. These are functions na ang domain ay ang set ng natural numbers, which is why we can use sequence functions in the idea of geometric and arithmetic sequences. Because instead of x, no, mas kilala natin siya as n in our formulas, whether recursive or explicit. And then we also define mathematical sequences. Ito yung range ng isang sequence function, ano? And each element is called a term in the sequence. A series is the indicated sum of a certain number of terms of a given sequence, typically denoted as S sub n, where n means the first number of how many terms we're supposed to add. So if it were, say, S sub 8 in the context of an arithmetic sequence, S sub 8 means the sum of the first 8 terms of that arithmetic sequence. No, it could also mean, kapag sa context naman ng geometric sequences, let's say you have S sub 5. Then you're looking for the sum of the first 5 terms of your geometric sequence. Okay? Recall lang ito, ha? Arithmetic sequences, series, naaralan natin to, no? When we say arithmetic sequence, this is the kind of a progression wherein the successive terms are obtained by adding a constant number, which we call the common difference D. An arithmetic series, on the other hand, is once again the indicated sum of a certain number of terms of an arithmetic sequence. Similarly, si geometric sequence naman, parang arithmetic sequence lang din, except that instead of adding the same number over and over again, here you multiply the same number, which we refer to as the common ratio, R. No? Paulit-ulit lang natin yung minumultiply. Okay? So far, ito yung mga alam natin. Formula-wise, ito yung mga na-derive na ninyo with the Mrs. Arespacochaga. Ano? Ito yung mga alam natin. Yung mga puti, nakikita nyo dyan, ito, si A sub n na formulas. These are formulas that you use to look for particular terms, no, of either an AS, an arithmetic sequence, or a GS, geometric sequence. Ito namang dalawang yellow, ito yung ginagamit mo kapag arithmetic series ang hinahanap mo, no? Now, can anyone tell me when is this best used? Paano sabi ni Ms. Raspacochaga? When is this best used? Si A, Formula B. When is either best used? Again, please don't raise your hand, just unmute. Paano nga yun daw best ginagamit? Anyone? Wala, nalimutan na. Yung first, yung formula A, ginagamit natin yan typically kapag alam natin kung ilang number of terms ang ina-add mo. Plus, tignan to ha, alam mo dapat yung last term, si A sub n. Alam mo kung hanggang saan ka lang mag-add. Okay? On the other hand, kapag yun, hindi mo alam, well, ang katasang kilala mo ay si D. Ang given mo ay common difference. O, gagamitin mo ngayon yung option B. Okay? Kasi yun lang din naman yun eh. A sub n really is the formula for determining the nth term of an arithmetic sequence. So basically, the second equation here, si formula B, was obtained by substituting this value, a sub 1 plus the quantity n minus 1 times d for a sub n. And you should get the same equation anyway. Okay? Ang wala pa tayo sa ngayon ay, papaano, sir, kinukuha ang sum ng isang certain number of terms in a geometric sequence. And that's what we'll be deriving today, no? Before we begin anything. Tignan to, no? We can write, ayun, lumabas din siya yung ating derivation. I just wanted to do it manually. So, yan yung ating equation. Bahala kayo kung ano gusto nyo tandaan dito. The first version, the one with the grouping symbol, or the second one. Ako, generally, I prefer the first one. I don't know why. Basta mas trip ko to. Mas madali siya nagsistick sa aking utak. Okay? Again, for any real number, for any R pala to, real number except for 1. Hindi pwedeng common ratio si 1. Right. Now, sample tayo. Find the sum of the first 7 terms of the geometric sequence 3, 15, 75, etc., etc. Okay? So, here, let's identify stuff that we know. We know that the first term is 3. We know that we are looking for the 7th term. Madali rin ma-determine kung sino si R. We simply pick out 2 terms here, consecutive terms, 15 and 3. And we divide 15 by 3. So, R must be equal to 5, of course. And we're looking for the sum of the first 7 terms, where R is equal to 5. So, again, our equation, we just write our equation here. S sub n equals a sub 1 multiplied by 1 minus r raised to n all over 1 minus r. Okay? Then, we plug in what we know. Si S sub n, salpak natin yan. That becomes S sub 7. A sub 1 becomes 3. R becomes 5. N becomes 7. And we simplify from there. Okay? Now, of course, dito sa pagdating na sa lesson na to, medyo importante na meron kang calculator. Kasi potentially, tulad nito, meron kang mga exponential expressions like 5 to the 7th na mahirap i-mental. So 5 to the 7th is, the entire thing simplified is this. Okay, I'm not going through the simplification any longer. I'm sure you know how to do your PEMDAS anyway. So 58,593 dapat ang lalabas niya na sagot. Okay? Pause. Questions so far? I'm looking at the chat box. Questions? Okay, mukhang wala naman. I'll carry on. Next. Ito, number 2. In your 20-week money saving challenge, you decided to save 3 pesos on the first week. Murang-mura, kaya-kaya. 6 pesos on the second, 12 on the third, and so on. Question is, how much will your total savings be at the end of the challenge? Now, from the hints laid out with from this problem, we see that we are in fact dealing with a geometric sequence. Our first term, we can think of our first term as 3. Yun yung tatipid mo at sinave mo sa unang week. Times 2, 6 pesos on the second. Times 2 again, for the third and so on. So every week, you save twice as much money than what you saved in the previous week. Twice as much money would indicate, again, it's a geometric sequence with r equals 2. Yun yung hint natin. Alam natin, a is 3, n is 20. We're looking for the sum of the first 20 terms in the geometric sequence with a common ratio of r. Kailangan natin i-add yan lahat. Kasi what you save on the first day is independent of what you save on the second and so on. So, i-add mo yun, no? Cumulative yan. So, yung 3 mo sa day 1, sa is mo ng day 2, 12 mo ng day 3, you add all of those together for the first 20 weeks. And the question is, how much will you have saved by the end of the week? So again, we use our trusty formula here. We plug in what we know. And if you might imagine, sir, parang ano lang yan nagsimula ka lang sa 3 pesos, 3 pesos. Tapos doble ka lang ng doble. Tapos 20 weeks lang, once a week ka lang magsisave. Hindi, maliit na pera lang yan. Again, this is when a lot of people underestimate the power, tawag dito, pun unintended, the power of powers, the power of exponents. Kasi if you notice, nag-start ka lang na 3 pesos, but you double it every week for 20 weeks. And how much will you save? Look at this, 2 raised to 20. That's not a small number at all, no? 2 raised to 20. So that will result you to how much savings by the end of 20 weeks. Ayan, meron ka lang naman 3,145,000 if you do that. Again, ito yung hindi natin napipicture kagad automatically na I start with 3 pesos lang pala, no? And I multiply it tawag dito by 2 every week. Yan yung I don't know if you've sort of encountered that origin story. I'm not even sure if it's a real story, the legend of the game of chess. Yeah, has anyone heard that? The legend of the game of chess, wherein this inventor, the inventor of the game of chess, parang presented it to the king as a present. And the king was so pleased with the game na he wanted to reward the guy who invented the game of chess, no? Sabi niya, sabi ng king or sultan or whatever, kasi parang sa Middle East yung kwento. Sabi niya, kahit anong gusto mo, I'll grant you your request because I'm so pleased with your gift na game of chess. So, itong chess maker, sabi niya, sure, sige, no problem. So, Mr. King, balik tayo sa game board, chessboard. If you can imagine your chessboard, sure. Your chessboard, if you can imagine, is an 8x8 square. 8x8 yan. I'm not gonna draw it completely. But it's 8x8, basically. And then the guy said, okay, Mr. King, this is what I want in return. On the first first square of the chessboard, I want you to put 1 grain of rice there. 1 grain lang? No problem. And on the second, I'd like you to give me twice as many grains of rice than in the previous box. So, in the second, it will be 2. 2 lang pala eh. Bigas lang gusto mo? Nakakatatlong butil lang yan 3 butil ng bigas O sa next, 4 na butil. No problem. Sunod, 8. Kayang-kaya. So, tinawanan lang siya nung king. Sabi nung king, sige, no problem. Yan ang pala gusto mo sa buhay mo. Sure, bibigay ko sa yan. Kaya lang, again, in-underestimate ni king yung power of powers. Kasi every time you multiply this by 2, it gets bigger and bigger and bigger. And imagine this. Sa 20th pa lang, 20th square. The 20th square should already contain 2 raised to 19 grains of rice. And you're not even halfway the 64 tawag dito squares. Halfway is 32 Diba? Imagine that on the 32nd box, you will have had 2 raised to 31 grains of rice. And by the time it got there, the kingdom did not have enough rice for that particular person. No? And in fact, if you compute the tawag dito, the actual number of grains of rice that had to be given to this guy, had it been possible, mathematically, if you put the grains of rice from one end to the other, it could actually go to the moon and back twice. Now that's how much rice generated by these powers. Kaya nga ito yung underestimation ng exponents is paano ba? Unwarranted because they grow. Kaya nga yung term na growing exponentially. Okay? So, milyonaryo ka na at the end of 20 weeks kung magsasave ka lang ng twice as much as you did in the previous week. Sir, can we do that? Sige, try. You can try. Start with 2 pesos. Double mo. Daily. Weekly, I mean. Okay? Next example. A ball is dropped from a height of 15 meters and bounces to 60% of the previous height. Question is, how far has the ball traveled up and down when it hits the ground the 4th time? Okay. So, one way to do this is you can sort of brute force, do it manually. What do you mean by that, sir? Pwede natin itong i-model I mean, literally by drawing, Again, sabi, a ball is dropped from a height of 15 meters. So, yung unang drop natin, i-model natin yan. So, from a certain height, nilaglag ang bola, boop, bagsak. Let's say this is the level ground right here. So, the first drop, the first fall is a 15-meter fall right there. Now, of course, because of the laws of physics and whatnot, the ball will lose energy once it hits the ground. So it should not really bounce up to the same 15-meter height. In fact, sabi sa problem, it only bounces to 60% of the previous height. Which means, once it bounces from the ground the first time, ang talbog niya ngayon pabalik, paakyat, is only 60% of 15. No? Which in this case is what? 9? Tama ba? 9 But let me not write it like that. I'll write it on the side, yung pagtaas niya dito. Tataas. Of course, it should bounce the same direction, But I don't want the two lines to overlap. 60%, Sabihin natin dito yun. That's 15 times 0.6. Aangat yan. But note, na kung ano yung inangat niya na 60%, syempre, from that particular height, yun din yung kanyang ibabagsak. Same distance. There you go. And when it hits the ground, it will have hit it a second time already. Tama? And then, once again, it should rise up 60% lang ng previous bounce. So, that's 15 times 0.6 times another 0.6. Ng 60% nung previous 60%. Babagsak uli yan dito for the third bounce. And then, different ink here. Finally, for a fourth, angat uling konti lang. That's 15 times 0.6 times 0.6 times 0.6. Diba? Technically, again, pwedeng brute force. Babagsak uli yan for a fourth bounce. Ang tinatanong dito sa problem, how far will the ball have traveled after or when it hits the ground the fourth time? So basically, itong mga line segments na ito, 1, 2, 3, 4, 5, 6, 7. We take the sum of all those. Again, you can do it by brute force. However, ano pa silbi na inaral natin ang geometric sequences kung brute force lang din natin, di ba? So we can try something here. We can kasi ang pag-bounce natin, remember, is only 60% of the previous. So notice that we are constantly multiplying 0.6, which would make 0.6 our common ratio. Tama? And then, what would be our tawag dito? A sub 1. What would you like your A sub 1 to be? Kasi there are two options. You'll see later why. No? Let's treat, kasi ina-add din naman natin tong first fall. Let's treat the 15 as our A sub 1. Okay? So, kung A sub 1 natin itong si 15, tingnan na mangyayari, no? In fact, meron dito naka-layout. Yan. R is 0.6. Ang N natin ay 4. We're looking for the distance it has covered when it bounces the fourth time. Okay? So, ito yung diagram, dinrawing ko lang kanina. I only redrew it because it might give you the impression, if I just showed you this diagram, might give you the impression that the trajectory is parabolic. When Hindi naman ganon. Kasi sir, bakit? Would it be different if it were parabolic? Of course. A vertical distance is different from a parabolic distance. So in the diagram lang naman, just in the drawing, para lang makita mo yung bouncing, no? Kaya may mga parabolic curves. But if it were dropped vertically, no, all things held constant, it should only bounce up and down and not in parabolic trajectories. Yeah. So just so you can visualize, this is what's gonna happen. So we are looking for S sub 4, basically, no? The sum of the first four terms of our geometric sequence. At kapag pinlug in natin yung mga alam natin, ano? In our formula, S sub n equals a sub 1 times 1 minus r raised to n all over 1 minus r. We will get this. 15 times 1 minus 0.6 raised to the fourth power all over 1 minus 0.6. Okay? And if you answer that, that should be 32.64. However, meron tayong dapat gawin kay 32.64. Anyone? Are we done with that final answer? Now you can unmute. Ano? 32.64. Yan na ba final answer ninyo? Kung test ito ni Mrs. Ares Pacochaga, yan na ba inyo sasagot? Or did we miss something? Anyone? Hello?
Sir, I think we missed something.
And what is that? What did we miss? What should we have done? Ano ba yung mga inad natin dito? Look, ha? We added the 15, then we added to it the next bounce, which in this case is 9, and then added 5.4, and then added 3.24. Pero meron tayong critical na hindi ginawa. Sorry, whoever that was who spoke just now. Ano hindi natin ginawa na dapat ginawa natin? Hindi pa to final answer eh.
Sorry, sir, I'm still trying to find it.
Sige, anyone else? It's not my only student. This is, I'm assuming a 30 plus. Sige, again, may narinig ako nagtaas ng kamay. Don't have to raise your hand. Just unmute.
Sir,
There you go.
Dodoblehin po yung A sub 2 tsaka S sub 2 tsaka S sub 3.
Dodoblehin yung S sub 2 tsaka si S sub 3. Si S sub 4, di ko dodoblehin.
Tapos si S sub 4.
So basically, ang sinasuggest mo, you're Mr. X. Mr. X, dodoblehin natin. Eh kung dodoblehin mo rin naman yung bawat term, tama ba? Parang dinoble mo na lang din itong sum.
Hindi po kasama yung 15, sir.
Meron siya sinabi. Dodoblehin natin pero hindi kasama yung 15. Ang question ko muna sa'yo, Mr. X, why would we double the sum 32.64? Hello? Still you? Why would we double it?
Kasi po ang tinanong po, how far has the ball traveled up and down?
Correct. If we did not multiply it by 2, ano lang yung makukuha mo na sum?
Sir, how it traveled down.
Very good. It's either up or down, di ba? If you did not multiply it by 2. It's only, tawag dito, either the downward movements or the upward movements, which in this case more refers to the downward movement because of the 15. Tama yun, yung sinabi ni Mr. X. Sorry, hindi ko siya nakikita eh. Si Mr. X lang siya, no? So, yes, correct. If we let 32.64 be our final answer, then we only accounted for the one-way direction, the downward travels of our ball. But no, we also should be accounting for the upward movements also. Diba? So, ang suggestion ni Mr. X, doblehin natin yung... Actually, it's not S sub 2. Ang dinodoble mo, Mr. X. Ang dinodoble mo, A sub 2. Not S sub 2. Kasi pag sabi mo S sub 2, that's the sum of the first two terms. Ang dinodoble mo, yung term. No? Not the series. But, try to think about it, Mr. X. May sinabi rin siya kanina eh. Sabi niya, sir, pwede natin doblehin ito, 32.64. Pwede ko yung doblehin. Pero hindi kasama si 15, sabi niya. So, tama ba ako? Pwede kong doblehin yung buo, then take 15 away afterwards, Mr. X? Is that a viable way to do it?
Yes.
Pwede. Could you explain to the class why you need to remove a 15 at the end?
Sir, because it said that the ball was dropped from a height of 15 and
Correct.
meters.
As opposed to,
The ball never goes up 15
very
meters.
good. Yung bola mo, inilaglag mo from a height of 15. 'Di ba? As opposed to being thrown upwards first at a height of 15 meters. Had that been the problem, then you don't have to subtract the 15 at the end. Tama, 'di ba? Kung hinagis mo muna yung bola pataas. Pero hindi ganyan yung nangyari eh. The ball did not have to travel the initial upward direction of 15 meters. No, it was dropped from that height. So, pag dinoble mo etong 32.64, that is counting the 15 twice. Assuming that is making the assumption that it was thrown upward, that it made a vertical, an upward travel first. But it didn't. That's why we take away the 15 at the end because, again, it did not make an upward travel. It was dropped from a height of 15 feet. Correct? Okay, very good. Naintindihan yun, ha? Galing. So, ito, we go 32.64 times 2, then take away the 15 later to get our 50.28 meter total distance. Ito ang final answer natin. 50.28. Tama? O, pause muna uli ako. Baka may nataranta, baka may naguluhan. Pause. Okay pa. No questions? Looking at the chat box, waiting for people to unmute. Wala. Okay, sige. I'll proceed. Oops. Now again, another option kanina would have been instead of using 15 as our first term, pwede kong gawin instead, i-count ko lang yung mga may upward and downward movements. Meaning, ang gagawin ko first term ko ay yung sum na kagad na 18. Look, 9 plus 9 na ako. Diba? Pwede rin na ganyan. Tapos yung pangalawa, ano yung pangalawa mo? 5.4 plus 5.4, 10.8 ka na. In fact, magiging ganun din yan. The common ratio would still be the same. But instead, how many terms are you summing up? If each term of your new geometric sequence will be the sum already of the upward and the downward movements, then you'll only be looking for the sum of the first 3 terms. Tatlo lang. Tingnan mo yung diagram mo, 3 beses lang naman yung tumalbog eh. 'Di ba? Kung hindi mo kina-count na tawag dito na kasama yung 15 mo. Okay? But for now, you're only not counting it now computationally. But if you do it that way, so what you're summing up is 18 plus 10.8 plus 6.48, pero tignan ha, itong 39 point something something, mag-add ka pa rin ng 15 mo sa dulo. Bakit? Kasi yung 15 mo, kasama pa rin siya dapat sa total travel ng bola. Hindi mo lang siya sinama kanina computationally. Pero dito, instead of taking away the 15, now you're adding the 15. And look, you still get to the same answer, 50.28. Diba? That's option number 2. Okay? O, diba? Pretty simple. Again, pause. Questions? Wala pa? Mukhang mahusay ang Bertio. Okay, sige. Walang mga tanong-tanong. Sige. Lipat tayo sa sunod. Ito, tingnan to. Suppose, in that same problem, same given information, 15 pa rin yung first drop. Find the total distance traveled by the ball until it comes to a complete stop. Complete stop. Titigil ang bola. Okay? Paano kaya ito, sir? Ang tanong, sum of the first which, how many terms are we supposed to add? Kung 15 ang ating initial height, if I take 60% of that, will I get 0? No? Hindi, di ba? Now, whatever the 60% of that is 9. If I take 60% of that, will I get 0? Hindi rin. I'll get something like, ano nga kanina, 5.4 ba yun? Now, if I take 60% of that, and 60%, will I ever get to 0, boys? Anyone? If you take consistently, 60% of a non-zero number repeatedly, will you ever get to 0?
No, sir.
Never. Diba? You'll never get to 0. In fact, ayun, sabi ni Batnag sa chat box, sir, never. Whenever you take 60% of a non-zero number, you'll never, ever get to 0. So does that mean that the ball never stops bouncing? Because it will always have 60% of a very minute distance to bounce off from. Ito yung isang paradox ng mathematics. In fact, merong ancient Greek philosopher, si Zeno. Kanyang Zeno's paradox, which we can model in different ways. But let's model it to something that you are familiar with. This is not exactly Zeno's paradox. A revision of it. Imagine this. You're still looking at the screen. Imagine you have a pizza. Yeah? A whole pizza. And imagine that after buying that whole pie of pizza, you promise yourself na, okay, just so I can savor this for as long as I can, I will only eat half of whatever I have every night. Yun ang pinangako mo sa sarili mo. Kung ano meron ka natira sa box, kalahati lang na nakakainin mo every night. Okay? So, one whole pizza, day 1, night 1, kakainin mo kalahati lang. Okay? Tanggal na yung kalahati. So, for the next day, Martes na halimbawa, kalahati na natira sa'yo. Uy, kaya lang, di mo kakainin ng buo yun. Kakainin mo kalahati lang nun. Oops, kalahati lang. Nag-diet ako. Minatira ka ngayon, mga 1/4. Oh, kakainin mo ba yung buo yan? Hindi, kainin mo lang kalahati. Wednesday night, kalahati. Tapos kalahati ulit, kalahati. Just like my question a while ago. Whatever the total surface area of the pizza is, that's a non-zero number. No? That's a whole. That's a non-zero number. You can even imagine it as a 1, a whole number 1. Etong buong pizza. How much pizza? 1 whole pizza. If you take half of 1, yun yung kinain mo on the first night. What have you eaten? 1/2, sir. Sure. If you eat half of that the next day, the next night, what have you eaten? The next night, 1/4, sir. Sure. And you keep on eating half and half and half and half. But remember, you only kept eating half of a whole. Again, mathematically, kapag kinalahati mo na ng kinalahati ang isang buong pizza, will you ever run out of pizza? Mathematically speaking? Never. Di ba? Never. Because you can never end up with 0 if you take half and half and half and half of a non-zero number. It's impossible. However, we know in the real world that you will of course run out of pizza. No? So that's that's a paradox. No? Wherein parang self-contradictory ata yan. It doesn't run out, but it will run out. No? And that's the same thing about the bouncing ball. We're consistently taking 60% of the distance from the previous fall. And if you take 60% repeatedly of a non-zero number, you'll never end up with a zero distance. In other words, the ball never stops. But again, remember, in the real world, meron kang mga ibang factors like loss of energy, no? Which is why the ball will eventually stop. But if we examine the mathematics of it, what will happen here? Let's do a quick exploration first. Tingnan to, no? In that same tawag dito, by that same principle. Imagine that by the end of 4 bounces, how much distance will be covered? Ito lang yun, no? By the 4th bounce. If you raise 6 to the 4th power. Kasi ito yung ating nagbabago no? Dun sa ating formula. The 0.6 at the bottom is 1 minus r. That will never change. But as you increase n, ano dito yung nagbabago? Ang nagbabago dito, yung expression mo na r raised to the nth power. Yun yung nagbabago as you raise the number of terms, no? And look at this. 0.6 to the third is 0.216. 0.6 to the fourth is 0.1296. If I increase it further, look what happens. Paliit ng paliit yung expression, yung expression na r raised to the nth power. So what does that mean, sir? If you increase n sufficiently large enough, the value that it corresponds to, r raised to n, will be negligible. Tignan habang tumataas ang n, paliit yung value ng r raised to n. If you imagine 0.6 to the 100th power, most likely it will look like 0.0000, sobrang daming zeros until something. So as you increase the number of terms in your sequence, no, the closer to 0 the value of the expression r to the n gets. In other words, what if you make it sufficiently big? Magzi-zero na yan halos. Halos ha? I'm not saying zero. It will be closer and closer and closer and closer to zero as you increase the number of terms. But sir, do we have that kind of a sequence which has a lot of terms? In fact, can you have infinitely many terms? Of course. Di ba sabi natin, we call those infinite sequences. Meron tayong infinite geometric sequences. And if you have, as many terms as possible, note how this value right here, oops, not that, here, r raised to n becomes closer and closer to 0. No? Granting that you increase the number of terms in tawag dito, and what you're adding up in the sum. What does that mean for your equation? Pag ito naging close to 0 na si r raised to n, that expression becomes negligible. Nagmumukha na lang yan na 1 minus, instead of r raised to n, becomes 1 minus 0. And what is 1 minus 0? That's 1. And if this expression here becomes just a 1, multiply it to a sub 1, we transform, therefore, our equation into something else. It becomes this. S sub n equals a sub 1 na lang yan sa ibabaw over 1 minus r. But not just with n, not just with any n, we do that when we're looking for the sum to infinity of an infinite geometric series. Oh, di ba? Pero may kondisyones, mga boys. May kondisyones. Hindi lahat ng infinite geometric sequences ay pwede nating hanapan ng sum. Pwede lang natin yang gawin. Ito, tignan mabuti ito ha. Ito ang iyong clincher. Pwede mo lang hanapin ang sum to infinity ng isang geometric sequence kapag ang r value mo falls within that range. The question is why? I don't really have time to prove the entire thing at length, pero when your r value falls within this range, the geometric sequence seems to converge to a certain value. Para siyang merong ina-approach na certain value. Which means that particular convergence allows you to take the sum of your terms, even though there are infinitely many terms. Again, that's the paradox. You have infinitely many terms, but they converge to a finite sum. No? And we have shown that mathematically. Kasi as you increase the n, value of n, you keep r raised to n as close to 0 as you can. So, tama? So again, this is our formula. In fact, we can change that a bit. Instead of s sub n, that's sum to infinity is equal to a sub 1 over 1 minus r. That's your second formula. Remember, we only apply this formula, we only use this for infinite geometric series wherein the value of r is between negative 1 and 1. Dun mo lang pwedeng gamitin ang formula na ito, sum to infinity. Otherwise, hindi mo yan magagamit. Okay? Pause. Questions. Importante magtanong dito sa part na ito. Kung meron man tanong. Wala? Okay. Then we can now use our, tawag dito, from that particular example, let's look at these sequences. Ito. Can I determine the sum to infinity of this sequence? Yes, no. That's a geometric sequence, by the way. Can I determine the sum to infinity? Yes or no, and why? Hello?
Yes, sir.
Yes, bakit yes?
Kasi po, 1 divided by 3 ay 0.33.
Right, no? Or 1/3. R is equal to 1/3, which falls within that range, no? Between negative 1 and 1. So yes, in fact, the sum to infinity daw is 9 over 2. Kapag tinake mo yung sum yan. Sir, how do you know it's 9 over 2? You can plug in what you know in the formula, no? Sabi natin, the sum to infinity is equal to a sub 1 over 1 minus r. What's the first term here? 3 over 1 minus, ano yung r natin kanina? 1/3. Oh, that will be what? 3 over 2/3. Diba? So what will that be? 9 over 2. Oh, diba? An infinite number of terms but a finite sum. Diba? So, elegant. Yan yung ating paradox in math. Paradox also in logic. But it works. How about this one? Yes, no? Hello?
No, sir.
No. Kasi ang R natin dito ay that's 7.5. No? 7.5 is what? 7 over 5 pala, sorry. 7 over 5. It doesn't fall within the range for it to merit na maging determinable yung ating sum to infinity. Ito, 10, wait, I don't think that's supposed to be a 10 minus 20. That's supposed to be a 10, comma, negative 20. Tama, pag inad mo, ganun din pala, no? 10 plus negative 20. 10 minus 20, correct. But is this, possible? Yes, no?
No, sir.
Hindi pwede. Kasi ang R ko dyan ay, doesn't it look like negative 2? Yeah. Pero, kung tama, mukhang negative 2, ano? This is 10, and this is minus 50. Yeah, hindi obra yan. Teka, ba't 2/5 ito? Tama, may mali. Ano mali dito? Kaya nga parang naguluhan ako eh. 10 minus 20, you can think about it as what? 10, comma, ito na yung gawin natin na sum. 10 plus 40 minus 80, negative 40. Tama, lumalaki siya eh. Negative 4. Hindi dapat, di ba? Ba't siya naging negative 2 over 5? There's something wrong with this particular item. It's supposed to converge to something. No? So no, just leave that item alone. May mali ata dyan. Right. Let's go back to the bouncing ball problem then. No? So we're looking for the total distance traveled until it comes to a complete stop. Hanggat tumigil sa complete stop. Hanggat tumigil yung bola. Now remember, kanina we took the a sub 1 already as 18. Yan na yung sum ng upward and downward movement. If you might remember what we did, up and down na yan. We took that to be the first term. Eto, first term. Yan. A sub 1 na kagad yung buong sum. Kaya siya 18. A sub 2 na kagad tong buo. A sub 3 na kagad to. But it will continue to do that to infinity. Mathematically speaking. Yeah. So if we take the sum of that, we have 45. But did we forget to do something again? Anyone? Final answer ko na ba 45? Hello? Meron ba tayo nakalimutan gawin? Huy, saan na kayo? Ito lang inad ko, oh. Look. Yan, yung mga pink. Wala ba akong nakalimutan gawin o i-add?
Sir, I don't think so.
You sure? Hindi, ay nyo isama tong 15? Sama na. Oh.
I think so.
Yes, sama natin yung 15. 'Di ba? Kasama part pa rin siya. Yung kahit may infinite bounces ka na merong upward and downward movements, it doesn't remove the 15 as part of what we're summing up. Tinreat lang natin siya computationally na hindi kasama para convenient yung ating a sub 1. Pero, itadagdag pa rin natin sa huli, syempre. Kasama pa rin siya sa total distance na tinravel. Eh. Di ba sabi ko kanina, same question, but the difference is we're now looking for the total distance it has traveled until it comes to a complete stop. So, we add the 15 at the end, giving us our final answer. Correct final answer, 60. Tama. 60 ang final answer ko, bali. Okay? Pause ulit. Questions? Mukhang wala pa sa chat box. Wala rin sa voice. Okay. Last na example. Ito. Ito yung mga, fun applications of geometric sequences. Find the fractional notation for 0.787878 or, sorry, mali ito. Typo ito. Or, this is supposed to be 0.78. May bar sa ibabaw. Hanapin daw natin yung fractional equivalent niyan. Di ba? Paano gagawin ko dyan, sir? Tingnan muna natin itong number natin na to. This is a repeating and non-terminating decimal. Okay? So, mukha ba itong geometric sequence? May application tayo rito. Pero tingnan, meron kang repetitive eh. 7, 8, 7, 8, 7, 8. Okay. Let's isolate those. Tingnan natin, ha. Itong unang 0.78, let's isolate that. That is 0.78. Tama, di ba? O ito, meron kang pangalawang 78. Is that 0.78? Parang hindi. Actually, that's 0.0078. Di ba? Itong pangalawa. Oh, itong pangatlo. Isn't that 0.123478? Ito yan. Di ba? And then, to get this decimal number, don't we add them up? Ina-add mo yan. O pag in-add mo itong mga 2.7, ito makukuha mo eh. Di ba? But look at these. How do you go from the first term to the second term? How do you go from the second to the third? Is this a geometric sequence? Parang oo. In fact, our R is equal to what? How do you go from 0.78 to 0.0078? What do you multiply? Or what do you divide? Sige, fine. Either way would be fine. Anyone? Wala.
1 over 100, sir.
1 over 100. Good. Or, if you want, 0.01. Tama? 1 over 100 natin. Very good. So, our common ratio is 1 over 100. Tignan to, latag natin dito. Ayan, oh. Ayan, 1 over 100 ang ating common ratio. And this is an infinite sum. Di ba? Kasi non-terminating decimal nga eh. So, latag natin ang ating alam sa ating sum to infinity. Oops, ba't tumaba? Sum to infinity will be equal to, again, a sub 1 over 1 minus r. A sub 1 ko, first term, 0.78 over 1 minus 0.01. And what is that? 1 minus 0.01. Oops, 0.01. Isn't that 0.78 over 0.99? Tama, di ba? Oh, magmukha na itong fraction agad, oh. Multiply top and bottom by 100. That looks like immediately 78 over 99. Ba, pwede. Pero alam ko, pwede mo pa simplify ito eh. Di ba? Etong si 78, divisible ba to by 3? Parang oo. Tanggalin mo ng 18. Meron kang 60. Tsaka meron kang 18. O ito, meron kang 20. Dito, meron kang, ano to? 6. O ito, 26. Over 33. O ha? O diba? May fractional equivalent. Yung ating non-terminating but repeating decimal. Try nyo, calculator. 26 divided by 33. Anong lalabas sa'yo? Dapat 0.787878787878. O, diba? Elegant. So, it's 26 over 33, the fractional equivalent of this non-terminating and repeating decimal. There you go. O, tama. 26 over 33. Okay? Pause. It's 9:45. Sakto tayo. Saktong-sakto. Questions? Pahabol. Wala. So, kung walang